Mood classification from face images by a nonlinear multi-class perceptron model. Contributors were Jaden Cho, Josh Foley-Comer, Silvan Loew, and Arnold Chan. The goal of this project was to develop a mood classification algorithm. We wanted to classify images provided from Kaggle. These images were grayscale images, so our first approach was to use the raw pixel values themselves. Another approach that we tried was one that we learned about in class, which was using the histogram of gradients to detect edge features. Neither of these initial approaches gave us good accuracy results. We looked into the literature to find hand-engineered features that could better predict the labels. One of the external libraries we found was able to create these facial landmark points from a face image. There are 68 points, and here are those 68 points laid onto a sample image from the data set. Those landmark features are in red. The relative positions of these features could help us identify the mood, and there was a paper that talked about this. Here are the number of images per each class, and these labels for those classes were surprise, fear, angry, neutral, sad, disgust, and happy. There's a bit of class imbalance as we see that disgust does not have a sufficient number of images to analyze and give robust data to, so we chose to omit that in our classification. Furthermore, sometimes this external library didn't accurately give the correct features, so we had to filter the poorly feature labeled images. Our method of filtering actually left us with 75% of the data of both the training and test data, but most papers were left with 60. And this 15% discrepancy more often meant that we had incorrect data that we were still analyzing. So after importing the data and extracting the features, we wanted to define a multi-class perceptron to do the classification. Here is the function that gave a nonlinear feature transform with polynomials. We found that the best polynomial was 3 and 4, but this code shows for 3. And the model for our classifier was a linear combination of these nonlinear features. Our cost function of choice was the multi-class perceptron, a regularized version of that. We removed disgust from the training and test data due to those insufficient number of images. One idea that we had was to first create superclasses and then further identify the individual labels from clusters of those mood labels, but this didn't give better results than just using a single layer multi-class perceptron to do this classification. We use gradient descent in our optimization, and we actually did a twofold cross-validation method. Here are the validation cost histories for each of those two folds, showing that gradient descent with 1,000 iterations and a diminishing learning step was the appropriate optimizer. We then chose the best weights from averaging between the two, and that created a final model, which we then used to predict the labels for the test set, giving us a balanced accuracy score of 40% or around 44%. And finally, to analyze our data further, we create a confusion matrix where the columns were the predicted labels and the rows represented the number of the true labels. And we see that we did better than random overall because the on-diagonal values are the highest in each column. And furthermore, we found that happy was easily distinguished from the other classes, whereas neutral and fear are easily confused with others. Methods of improving this model would be to create or look for better features, first of all. And also, we could also try multiple layers or even try a neural network.